Hi, let's look at this question given as 1 over x squared plus 4x plus 5, and we are required to integrate with respect to x. So, when I come across such questions, like questions of this nature where it's a rational function, the first thing that comes into my mind is like, am I able to use your substitution? Or am I able to break down that particular function into its equivalent partial fractions? Then I go ahead with the integration. So if I think of use substitution on this particular question, it can't work out because of the nature of the numerator. I just have a constant number, which is a 1 for my numerator. Then when I think of breaking it down into its equivalent partial fractions, I'm like, no, I can't do that simply because I cannot factorize the denominator. Okay, you might think to say, why am I talking about factorizing? It's because factorization of the denominator in this case is like, okay, it's very important when you are trying to break down a function into its equivalent partial fractions because you cannot break it down just the way it is here. Okay, so unless if let's say the denominator was factorizable such that maybe it was x squared plus let's say 5x plus maybe 4 here, or maybe it was x squared plus 4x plus 4. We can factorize any of these, but we don't have any of them. So the question is, how do we do it? So one thing I would love to highlight in this video is the importance of knowing how to complete the square, because when you come across such questions, being able to complete the square of a given denominator of a given function is very important. It's going to help you a lot. Okay, so if you complete the square for the denominator, this is just to end up to like x plus 2 squared plus 1. So this here and that are one and the same. So how you complete the square for this one is very simple. It simply means you're going to say your x squared plus your 4x, and then you're going to add I'm going to say this is supposed to be minus b over 2 squared minus b over 2 squared, like that. Okay, remember to say we still have a plus 5 there. So this is just going to be more like you have your x squared plus 4x plus, what is my b? My b term is this 4 that I have here. Okay, so that would be more like minus 4 over 2, which would be minus 2 squared minus, it will also be minus 2 squared here plus 5. So adding this here does not change the meaning here, because what you have here gives you what? Gives you a 0. So I've not changed the meaning. So I may say, why are you adding that? You have changed the meaning. I've not changed the meaning. So you observe to say, finally completing the square for this one is that you're going to have your x, which is this one. Then you pick the sign that you have here, which is positive. Okay, then this one is just going to be positive 2, then squared minus, which is this minus, then minus 2 squared is going to be what? Is going to be 4, then plus what? Plus 5, giving you x plus 2 squared plus 1. That's how I got this one. Okay, so now let's bring it down. So this will now be more like the integral of 1, okay, 1 over uh, so here I'm going to write it as my x plus 2 squared plus 1 dx. So this looks familiar because I can choose to use trig substitution. How can I manipulate what I have here for me to enable it for me to enable me to use trig substitution? And it's very simple. I can write what I have here in terms of a letter. So let me say, let m be equals to my x plus 2, meaning my dm is going to be equals to dx. Okay, so I'll come here and say integral of 1 over, okay, to be 1 over, so instead of having x plus 2, I'm going to write m squared plus what? Plus 1, and my dx is nothing but dm. Okay, so remember, if you are to use trig substitution, looking at the nature of the denominator here, this would just be something like where we're going to say our m will be equals to a tan theta, and because my a is equals to 1, so I'll just say m is equals to tan theta, of which my dm will be equals to sec squared theta d theta. Okay, so we can continue with this, and this will be like 1 over, that to be 1 over, so where we have m there, we can put tan squared theta, because our m is tan theta. So if you put it, it becomes tan squared theta plus 1 multiplied by dx, sorry, multiplied by dm. What is our dm? It's a sec squared theta d theta, like that. Okay, so if you are familiar with trig identities, you remember to say your sec squared theta is nothing but tan squared theta plus 1. So meaning you can cancel out that one together with this one. So integrating this one, this just remain to be 1, because it will just be more like integral of 1 d theta, and it will just be what? It will just be theta. But you're not yet done. It's simply because initially you are dealing with the variable x, but I have a theta, and at some point I used m. So you have to ask yourself, what is your theta? You observe to say, because my m is equals to tan theta, okay, meaning my theta will be nothing but arctan m, or tan inverse of m. So here you can say my theta is equals to arc, let me actually just write tan inverse. This is tan inverse of what? Tan inverse of m, like that. But again, you are not yet done. I can't just leave it as tan inverse of m. Remember, initially you are dealing with x instead of m. Okay. So now, how is this one going to be? So you can say it's tan inverse of m, but I'm not going to write m here. What is our m? Our m, we said, is equals to x plus 2. So you can put your x plus 2 here, then plus what? Plus a constant of integration. Then that is going to be your answer there. So the takeaway from this question is that there are times when you are unable to break down a function into its equivalent partial fractions, and you are unable to use substitution. What you do is that try to complete the square. Perhaps if you complete the square, you'll be able to use methods such as trig substitution, or any other method that might be suitable for a question that you might be dealing with, because each question comes with own like there are some methods that are suitable for you to use when you are integrating certain questions. So that's how we go about that one. Thank you very much for watching, and we'll catch you in the next one.